Good morning, everybody. Thank you so much for joining us. I am just elated at the call that we're going to have today. Cathy Zabinski, and we did have Casey Bailey on as a guest, but he wrote us last night saying, I've got the Rona. So he is down with COVID, but we're going to talk about the collaboration that Cathy and Casey had as advertised, and then talk about some other things too. Um, this is OATS, the Organic Advisory Call Series, and we are recording today's session for the benefit of those who can't attend us live. I'm your host, Nate Powell-Palm, the training specialist with OATS, and this series was brought to you by the Organic Agronomy Training Service. This is our 17th episode, so please visit OATS website to review the call schedule and list of topics. And if you haven't done so already, I highly recommend signing up for the newly launched Organic Advisor Listserv. We're going to have some great conversations right in your inbox on all things advising organic farmers, and the link is going to be in the chat. And that's mostly it for housekeeping. So welcome, Cathy. Really excited to have you here today. Cathy and I go a ways back, as she was both my boss in high school in the lab I worked in, and is my major advisor in my undergraduate program in soil science. Cathy has her PhD from University of Minnesota and started out as a wide-ranging plant ecologist and has seemingly narrowed in on the world of sustainable ag. She is the 2020 author of Amber Waves, which explores the history of human relations with wheat. Cathy, welcome. Could you tell us a little bit more about how you made that leap from ecology into agriculture, and especially into sustainable organic agriculture?
Yes. So I grew up in northern Minnesota, which is not an agricultural part of the country. It's, iron mining and the boundary waters, lots of lakes. And so I did not think very much about agriculture. My PhD is in plant ecology, and I studied forests and genetic variation, but was really interested in soils and what was going on below ground. And after my PhD, I worked in California with the Forest Service Research Station and looked at basically studied a tree species that grew on all kinds of weird soil types, sand dunes and serpentine soils, which have very unique chemistry. And but there started studying mycorrhizae and the role of this plant fungus symbiosis to help plants grow in really unique environments. After that, I moved to Montana, first to Missoula, and began doing work in metal contaminated environments, still nothing with an agricultural hint to it. And but then a little bit maybe, then also in weed infested rangelands, and thinking about what is happening when you have a disturbance, either metal mine tailings or an invasive weed that takes over a native plant community. What changes in the soil relative to the soil community, and how might those changes affect the way that plants grow? So now you can see the link, like, oh, so we're thinking about increasing plant growth, etc. So I continued in that vein for another, 10 or 15 years, and working in high elevation recreation impacted sites, also like beautiful spots like Mount Rainier National Park and in the North Cascades, and still building this understanding of what changes in the soil, and how, as a restoration ecologist, how do we manage those changes to increase revegetation? And then after a sabbatical year, where I had time to think and reflect on stuff, and my sabbatical year was in France, and I was learning a lot about really this regional specialization in different foods and thinking about how people were growing their food, I realized that these questions that we ask in a restoration context, what happens with disturbance? How do those changes impact the functioning of that system? And what can we do to restore some of the missing components? Those questions could really be applied to agricultural land to help us to better understand how do we shift from kind of high input, intensive agriculture to a form of agriculture that places more reliance on the way the system works. And then I was hooked. Then I started learning about food systems and agricultural systems, and thinking about some of the same questions that I had been thinking about for my, most of my research career, like organic matter inputs, like what kind of organic was, so soils need organic matter in a restoration. They really damaged soils, maybe that's one of the first things we need to add, but what kind of organic matter, and what is it about the organic matter that's improving the site so that we can think about how do we add the best organic matter. So agricultural lands are so compelling, as you all know, because they're related to food production. And as an ecologist, clearly the importance of thinking about our agricultural lands in the context of the rest of the landscape is really important. And in the future, with increasing demands on food production, those agricultural lands are going to be asked to play more roles in terms of ecological refugia or whatever. It's going to require a very different way to think about land than as opposed to we've got a whole state that's we've converted into corn and soybeans or whatever. Like, we're not going to have that necessarily luxury in the future. So I'm hooked on these questions of how do you increase the soil processes and functionality to, same question, to increase plant growth. And in this case, it's crop and crop productivity. So
to get started off, I have just sort of a thought question for you, and that is, what would you think of as the largest disturbance in agriculture? When you're thinking about what disturbs the site, would it be chemical, physical?
Well, I mean, so let me rephrase the question. So
Please.
I don't know what the largest, so dependent on the site. Clearly, if you've got a lot of chemical inputs, chemical could be the largest, but even let's talk about, the optimally managed organic farm, the process of harvesting and working the soil and just removing all that plant matter from how do plant systems, how does a plant community function?
Yeah.
That's plant material in the soil has just a huge amount of impact on the physical and the chemical and the biological functioning of the soil. Now you're telling me you want to take that all away and sell it? Like, I mean, great, because I eat, but that's just a huge disturbance. That's kind of inherent to agriculture. And that's what makes really ecological agriculture a really interesting problem from an ecological perspective.
You've started working with a lot of different farmers around the state, around the country, but a recent collaboration with Casey Bailey and some other folks around Montana really kind of piqued my interest, partly because when we look at the problems that we see in ag research, oftentimes traditional sort of scientific approach is that we need to take the problem, put it into a trial setting, or an experimental setting in the university, or in a research plot. And there's just always so much lost when you have to eliminate variables and eliminate those factors that are usually tricky to do science on, but inherent to a commercial operation. And so could you tell me a little bit about how you see the path towards working with farmers so that they can incorporate a more realistic setting when they're doing these trials to get very context-based results or ask very context-based questions?
So I wish there were a really easy answer to that. Like the solution is da 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 da. But the challenges of that are really interesting to consider for both scientists and for farmers. I mean, anybody who farms or any farm that I've been on, you know very well that there is a lot of variation within a field and between fields, etc. So if you want to know what, so pick something, I want to test this product versus that product versus a control, or maybe I just want to test one product. So, as a farmer, not thinking about experimental design or anything else, maybe you're like, okay, this year I'm going to try that and see how everything goes. So you try that product on your fields. We turn out to have a great precipitation year. Everything looks great. It's like, wow, now I'm a believer, like I'm going to use this product because my yields are so much better. So in the science perspective, we want to say, okay, you got to split your field, and then you've got half with the product, half without the product. Well, in fact, this side of the field, always you've got to, soil shifts a little bit to clay, but you know that. So, okay, don't split it so that one side of the field is better than the other. Split it in the other direction so that each of your treatments has some of the clay. Well, that's just one side versus yet maybe I've got some kind of nematode or something else that's coming in from the one. So, all right, we can do 6 pairs or 5 pairs, whatever. And then we can really understand, was this product better than no treatment at all? So now you've got this fussy, what you have to be doing in your field is thinking about how big are my plots. It's got to be related to the equipment size. How do I set it up? And that's all well and good if you don't have too much other stuff going on. I have not really met a farmer who doesn't have too much other stuff going on.
Yeah.
So that's how we think of it as a scientist. Like, oh, it gets complicated right away for us to be able to generate the kind of data where we can look at it and say, statistically, this has about an 8% increase, in productivity. Is it worth the cost to you? From a farmer perspective, I can totally understand why these plot trials are the plot trials on our research farms that allow us to say, okay, I know this field is fairly homogeneous. I'm going to put in small plots. I've got a smaller seeder and a smaller combine so that I can do a harvest of my treatment more efficiently. And I can watch for the weather and make sure that I'm planting my strips and harvesting those strips on the right day, because I don't have all these other acres to manage. So that's that's kind of the inherent difficulty. So I'm doing on-farm research now, and with grad students, and each grad student has a committee with other faculty on it. And, the other faculty on the committee are always, will point out like, oh yeah, well, that's going to be a case study. If you're working on one farm with multiple plots, you're going to be able to publish that as a case study. It's like a story, and it's not going to allow you to do, I mean, you could on a single farm set up plots. It's not necessarily a case study, but we're just collecting data in fields that are farmed as the farmer is farming. And, you know, the difficulties from a science perspective are, well, my different treatments are different fields. And the only way that I can avoid the inherent difficulty, because that field is a little bit higher, soils are a little bit different, this area is pretty far away from that, and the rainfall patterns are different. The only way to get around the inherent difficulty of the differences between the field right at the outset is to do this over time and, look at patterns over time. So that involves more grant funding than I'm able to get at a single time, like a grant cycle, 1 or 2 or 3 years max. And the likelihood of me going back and saying, okay, we just want to extend this, a funder is going to say, oh, we can extend this one, or here's a new idea. That new idea sounds more compelling. So there's all this built-in difficulty. As a farmer, you've got your plate full with a whole bunch of stuff. As a scientist, we've got this, okay, how can we get funding for this? How will we be able to publish this? Because if we don't publish it, we won't get the next grant to say, because we're not, we've got to show that we're the right people to give the money to, because we publish this research. So it's a really interesting challenge to find that middle ground. So I'm past a lot of the hoops in the academic system where, your first 6 or 7 years, are you going to get tenure? You're going to want to do research that it will be publishable, that will turn around quickly. As you get more advanced in your career and you're like, they can't really get rid of me unless I do something horrific, you can take more risks and say, all right, I'm going to do this kind of study. It's going to take me 5 years to get any data that I can publish. So my publication record's going to be a little lower, but I'm interested in this. So it's not really a trivial barrier to just say, we don't really like those plot trials, let's do on-farm research. Does that make sense, Nate?
It does. I've sort of 2 follow-ups to that, but the first one, could you tell us a little more specifically about the questions you're asking with on-farm trials right now around the state, say with Casey or other farmers, that have been appropriate for that context which you just described?
Yeah, so we're funded through Western SARE, and what we're looking at is related to soil health. And so soil health is another concept that causes me just to sigh. As a scientist, it's a really interesting time to be a soil ecologist. When I started my research, nobody talked about soil health or soil ecology, or it was very little. And certainly farmers and practitioners didn't talk about it. It was really, kind of a nerd thing in academia. And now everybody knows about, trees are communicating, and, there's just all sorts of stuff, but which is great on the one hand, and it's got some issues on the other hand. Soil health to me is a challenging issue. Obviously, it's important, but how, as a scientist, do you talk about it? So it's a little bit like human health. So, okay, I can hurt my Achilles tendon, but I can be otherwise in great health, but I can barely walk. So I'm a mess. We can agree on that. Okay, then my Achilles tendon is healed, but now I've got a sore throat. Okay, we can agree, like, Cathy's a little bit sick. Then I get COVID. Okay, Cathy, like, there's so many different ways to be sick. And
Yeah.
there's so many different solutions to address that. And so how do you go out and say, all right, can you do some kind of assessment and tell me if I have healthy soils? Well, you know, soil organic matter is like one of the things that you could measure and say, if you are increasing your soil organic matter, we know that organic matter has got all these great things it does in the soil, everything's good. But the farmers in North Dakota are so far ahead of the farmers in Montana just at the get-go because they've got more, in general, precipitation and more biomass production, and their soils have higher organic matter. So does that make Montana soils like a bunch of wimpy, like, oh, they're all terrible? No. So it's relative to the context of, it just as a, you can start to see, like, should I be measuring organic matter? Should I be measuring soil processes? Should I be measuring soil community, like the biota? And the biota, okay, a healthy soil has, I don't know, 23,000 bacterial species. Yours has 14,000. Is that a problem? Or is it like, great, you've got 14,000 bacterial species? Like, but what if you're missing the right ones that really are, positively impacting your crop? So anyway, the problem with
As you
scientists is we jump into the details right away. But so large question that I've been trying to pursue, or that I am pursuing over the last years, has been, how do we reasonably address soil health, and what kind of metrics can you put together that would make sense? And I'm focusing on Montana because I just find it really interesting, like, especially in a semi-arid system where we don't generate that much biomass on an annual basis. We're not going to have big changes in organic matter with cover crops in one season. Or if we do, we're going to use a lot of the soil moisture that would be available for growing the cash crop the next year. So how do you manage all these different factors and come up with a realistic assessment of soil health? So I'm working on a few farms with producers who have really wide, like a lot of different crops in their crop rotation. And so looking at how does your choice of crop affect the soil parameters and the things that I'm measuring. I started out really interested in the soil community, like in my restoration research, mycorrhizae and bacterial species and the diversity of below ground systems. And it was actually working on mine tailings that inspired me to abandon that approach, in fact. Not necessarily with mycorrhizae, but thinking about diversity. Is it okay to go way off on these asides, Nate?
Sure.
Okay.
Let's
So,
hear it.
because it's really interesting. So this is totally not agricultural land. It's mine tailings, but you've got, this system of, okay, it's really low pH, really high metals. There's just a few mustards that want to grow on that site. And then we can change the pH by adding lime. And now you've got more plants. The lime means that the pH is such that the plants won't take up the metals. So now you can grow more plants, but fewer. So we've got this gradient, and I can measure functional diversity of the microbial community across this gradient. And it's, really low on just the mine tailings. And then I've got an undisturbed adjacent site. It's really high. So that was great. And then somebody from the EPA called me and said, oh, Cathy, the work is great. What I would like you to tell me is what we should be at so that I can work with mine reclamation plans and say, when you're doing your reclamation of these mining sites, this is what your microbial community should look like. So this was exactly why I went to graduate school. I wanted to be able to have an influence on decision making that impacted the, conservation, the ecology of places that are dear to me. And I could not answer that question. And I thought about it hard. It's like, well, for the same reason I can't answer it in an agricultural field now. How many bacteria should you have? What, what's it's different if you're talking about a plant community, because there's, 40 or 20, like the number of species that are there are something that we can think about and manage. But in microbial systems, it's like, wow. So I decided that I was going to shift from, trying to catalog who's there and what the diversity, et cetera, looks like, to thinking about what are they doing? Like, what are the functional processes in the soil that you want on your agricultural fields? So I'm looking at things related to nitrogen mineralization, like how is the organic matter breaking down and releasing nutrients? I've been looking at soil enzymes, and soil enzymes are just the weirdest little things. They catalyze a reaction, and in this case, it's related to phosphorus availability, nitrogen availability. There's different enzymes that do specific things. And the thing is with these enzymes, they're just like these proteins that are floating in the soil and produced by bacteria that say, wow, it's better to put this out in the soil and break down the nutrients, and then the bacteria can just absorb the nutrient rather than absorbing the big piece, and breaking it down within. So how are the soil enzyme activity changing across these, different treatments? So, and then there's other measures of like different components of the organic matter and things like that. And so my interest is, how do these measures change when with different crops in a crop rotation scenario? Because then you could say, oh, this field, if this worked, like if there was a tight link, you could say, this field, I need a little bit more, I've got to choose between these different crops. Why don't I put this one in? Because I know that this will have a bigger impact on this component of soil health. It's just, isn't that a lovely question?
Well, and how do you, I guess this is a conversation, as you said, that's exploded for
Yeah.
like, what direction do we run with soil health? And I think there's a lot of prescriptive, even sort of a national prescriptive sort of model where they're saying you should have these parameters. When you're thinking about kind of backwards engineering or back engineering for figuring out what is the goal and then how do we get there, how do you think about what the goal is? Or where do you look in either a farm or a natural system to say, this looks good, let's study to see what you have and see if we can move towards it?
Well, so this is the other thing that I just added to my research, is that we are measuring all these parameters in uncultivated spots adjacent to the fields to try to get the sense of, okay, once you're cultivating the field, speaking of big disturbance, how do these parameters change? And so we're just analyzing this data, and you should ask me in 6 months to get a better sense. But we've got it from a year ago, and now we've got our second year data on one site, and and roughly, at the outset, I guessed that I think a lot of our measures are going to decrease by half once you cultivate. And that is roughly what we're seeing. And what I don't know is how consistent that is. And we're trying to do that wherever we're measuring. Does that mean that our fields should be back up to where uncultivated lands are? No, not realistic. But partly what I'm trying to get at is I can measure statistically significant changes in, let's say, soil enzyme activity or potentially mineralizable nitrogen. But that shift, like, is that just a tiny little blip relative to, the uncultivated? Or at what point are things ecologically significant.
Yeah.
One of the issues that I struggle with as a researcher is that, and I can say this because I'm, tenured and everything. Sometimes I feel like we put a lot of effort into trying to quantify, to measure what in some ways feels like common sense. And,
Mhm.
Yeah.
Well, I think folks, for those of you on the call, please drop questions into the question box, and we'll have an iterative conversation. But I'm thinking about, in my work as an organic inspector, there were quite a few questions I've seen asked in the university concept or context, and you see farmers just saying, "I'm just going to try that practice. I'm going to sort of perfect it for my system." And the mechanism of why is seemingly it's just not invited to the table, in sort of a good way of not letting the perfect be the enemy of the good. I don't need to know why yellow blossom sweet clover grown with wheat makes a functional system for a lot of farmers in Montana to capture their, or to rather replenish their fertility. When we look to organic, I think that is so the case in a lot of ways, that it's just we have these practices that are going to be, like you're describing, so complicated that to flesh out one, or to fish out one little thing, might even just be a fool's errand, because you're not going to be able to describe that context. And so when we're thinking about like the advancement of organic research, but especially just organic acres, that always being the big question, right? How do we get more farmers feeling like they are safely farming, that they have enough research, enough information to do a good job? What is that? How would you see that sort of interaction between, we want to do good research, so we're not just peddling, theories, but we also need to be, admitting that it's, place-based, that there's so much context, it's hard to pull it out, plot trial by plot trial. And so what should, like, the farmer's goal, or organic agriculture's goal in general, for research be, as far as asking these big questions that help farmers in the maximal way?
Yeah. Wow. Interesting question. And I would love actually to throw that out to the audience.
Mhm.
Also, in some ways, and I'm just one researcher, I cannot speak for the research community. I have a really specialized area of research. I think a lot about what happens in the rooting zone between plants and microbes and all of that, and then I'm applying it to an ag setting. So, there are a lot of people with an agronomy background or soil fertility background who would answer this question differently. So keep that in mind. And my apologies to all of my research colleagues, but sometimes I feel like, wow, there's nothing I do that's ever going to, improve organic agriculture. I'm going to get at these fussy little questions. And, I don't know. In some ways, I feel like, this is another aside, but I feel like I go to I feel like a buzzkill at meetings because I'm really skeptical of a lot of products that people are peddling to add to fields, and the difference between talking to me and I'm saying, oh, really, if you want the right microbial community in the root system, or if you want a healthy biotic community, don't worry about adding different bacteria or fungi to your soil. Like, think about your soil, think about the organic matter, treat your soil as a system. The microbes will take care of themselves. Exceptions to that, obviously, with, sometimes we add inoculum for specific pulses and
Yeah, legumes.
but
Mhm.
so versus the next person who's selling the product saying, hey, I'm gonna, you can increase your yields by this much, and in 5 years you're not going to ever have to think about fertilizer because you're going to have such a healthy microbial community. It's just going to do it all for you. And like, geez, anyway.
Yeah.
What kind of questions can the organic community ask from a research perspective is so, it's everybody's fields, everybody's farming situation, everybody's challenges. The question is, are there some universals in there? Clearly, I would guess invasive species or weeds are going to be probably the closest to being universal, and managing the soils, and yeah, I don't know. It's when we're talking, I realize, we think I, as a soil ecologist, think at a really different scale, this really fussy little fine detailed scale of what's going on. What I'm so impressed with when I'm working with farmers is that they are, in fact, dealing with as many details as I deal with, but just on this really big scale. Like, what am I doing in that field, in this field, in that field, and seeding, and and the rain, and I mean, it's impressive. So in some ways, we've got really parallel line trajectories. And I guess what you're asking, Nate, is how do you either move those parallel lines closer together to operate at the same scale, or create some weaving to connect those?
Yeah, or even just thinking of, as there's always ideas being thrown out there for farmers to consider. Sometimes bugs in a jug, or it's just a practice, like a new type of crop or a new style of seeding. And when farmers are thinking about how they kind of prove it out for themselves, and don't lose the farm in the process, but also ask a question that they kind of can answer. Like, if I plant yellow blossom sweet clover with wheat, what would be significant of my findings or for my findings? And it probably wouldn't be necessarily analyzing the microbial community. It could be, but that it's just yield. Am I seeing my wheat protein high enough? And so I think when we look to, and I'll get back to this funding question in just a second, but when we look to the national conversation about how organic engages soil health, oftentimes I feel like organic is sort of kicked out. One, for the excuse that we till, but two, that it's a little too complicated for folks to be able to say that we can reasonably identify a goalpost. And I know we've had this conversation before, where what organic farmers want is very diverse, because organic farming is very diverse. But honing in on things like soil health and what that means to organic farmers, other than and I think I've heard this more than once, of the golden unicorn just being organic no-till, and asking that question of, is that the golden unicorn, and why? And I think I would be so curious if your thought as to how at conferences, in farmers groups, everybody can kind of stress test this question for themselves. What is my goal and why? And how you would put some parameters on that. Or to not say the world is just so big, I'm not going to try to do much innovation as a farmer.
Well, again, it goes, so I don't know. I'm going to say I'm stumped by that question.
Okay. we can flesh it out with some other things.
Yeah, so to start with, I hit a barrier right away with, okay, soil health, like what aspect of soil health are you talking about? And what kind of problem do you have in your field that you're trying to address? So, tillage and repeated tillage, the impacts of that are, we could talk about soil erosion and decomposition of organic matter being hastened instead of the organic matter being buried and a little more protected. We can talk about soil moisture, especially in a semi-arid system. Those are all relevant things, but this measure of the soil processes are decreasing on these fields relative to the adjacent uncultivated by 50%. Some of those are on no-till sites. Like cultivation is cultivation.
Right.
So you've got that. And so how and when and how frequently you till is going to have a big impact. It's like anything. So yeah.
Jumping over to that, the point you made about grant cycles being a poor fit time-wise for getting relevant, respectively significant data. I think about research funding a lot. In National Organic Standards Board, we give out research priorities, which go to OREI and get disseminated with a big announcement every year for what scientists got, a couple of $1 million recently to study what problems. And oftentimes I ask the question, mostly to myself, how do we improve this funding mechanism so that we put more value on the long term and the systems analysis approach versus this hunger for quick results? And is that a functional, NEFA change in NEFA's funding model? Is it that we have to say we shouldn't look at less than 5 years data, and so we need to find, funders who are able to engage on that timeline? Or how do you think we need to fundamentally change the question about funding this research? And what is that a better timeline?
Oh, Nate. You ask.
I realize it's 7:45 a.m. your time, so I'm chasing it.
Yeah. So, what the ecologists did is they set up these long-term ecological research sites. They, and so they said, okay, we're going to pick different biomes, and then we're going to keep these not for 5 years or 10 years, but for decades. And then people can come and work on these sites. So that's great. Except that's not really an agricultural scenario that, okay, we're going to pick one farm in Montana and then one in Pennsylvania, and then everything that happens on that farm is going to inform the rest of the community. Like, no, there's way too much variation, and you use different crops. And, when I talk to farmers here, and I've been working on a project in France about, so how much information do you get from, the research center, like the scientists who are in your area and doing research? Like, how helpful is that? It's really interesting to me because, I've got a sense of what people say in Montana, but then to go to France and, hear some of the same kinds of things, like, well, they did that research on a farm that's got soils that have nothing to do with mine, and so I can't, none of that is applicable. Or, oh, it's really helpful because we've gotten these varieties, whatever. There's a wide range. So to go back to the question, how do you change the funding cycles, and what would be the optimal time frame? The optimal time frame in Montana is going to be different than the optimal time frame in Pennsylvania. Definitely, I feel like if we've got changes in soil organic matter due to cover cropping or some other management technique in Montana, that's going to happen slowly over time. Just because there's so little biomass per year relative to systems that, have much more generous precipitation patterns. I don't know how to, I don't spend much time thinking on that large scale of, how do you manage research programs, et cetera. I would say, here's the scale I do think about. I have a call for proposals, and, oh, we want you to work on at least 5 different farms, and, da 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 da. And for me, as a researcher at the university who's also teaching classes, and so I've got things that require me to be on campus during the semester. One thing that would be really helpful to me is to, for example, if organic farmers said, here is a little compendium of farmers who are interested in working with researchers, and this is what their systems look like briefly, like this is what they grow, this is kind of the environment. And then I could look at that and say, all right, where are they located and what are they growing? And here would be, oh, here's 3 that I could work with, but then here are these other 2. It's not that hard to add 2 more because, or it is hard, but it's worth it. As opposed to the situation I'm in now is like, oh, I need 5 producers. Like, who do I know? Who does my colleague know? Who can I talk to at NRCS who might know somebody? And then cold calling people, like that link to farmers could, it could help researchers if you had a list of these are farmers who would be open to it, open to having fields sampled, open to maybe splitting some fields and trying some strip tests or whatever, or open to, I need some advice on how to set this up, but I'll do it myself.
Yeah. Yeah. So almost a database enrolling producers.
Yeah.
For researchers. I love that. In thinking about the sort of data collection in general for organic research, and how I've always hoped that there would one day be a way to gather the practices in real time that are going on, and make that data somewhat easy to aggregate and then make assessments without needing to necessarily set up the plot trials, just by seeing what practices resulted in what yields or soil loss or what have you. Do you see any, I think when we think about John Deere or precision agriculture, there's a lot of equipment that is inherently gathering data that private companies mostly get access to. In organics, do you see any obvious data set that we should be mining or looking at, or if we could mine it, we would be able to make some strides in understanding these systems better? Or is there just not quite enough data being kept on organic farms yet to
Yeah.
jump?
I don't know. You know what? That, and I'd have to say, I feel like I you ask good questions. I feel like I'm in my comprehensive exams from grade school. Like, my brain is going in 7 directions early in the morning. So I don't know the answer to that question, but this is what I will say. As we're talking, I think about, I'm sure, and I know of at least 1 or 2 attempts to put together some kind of directory. So I know who the farmers are, the farmers know who the expertise is. Those things, I'd have to say, are practically useless unless they're maintained.
Sure.
And, they're good for 1 year and then nobody looks at it. What
Mhm.
would be really interesting, and it would take a significant investment because it would be at least 1 full-time person, if not more, would be to pull together. I don't know the answer to the question because I don't know what data sets are out there, and you
Mhm.
don't either.
Yeah.
And you can comb the published literature, but there's a big sieve to what gets published. Like, did you get significant results? Did the student write everything up in a form that could be published? Is the advisor too busy to get around to that data and publishing it? To think about generating in Western SARE, I feel like SARE is really trying and fairly effective at having a compendium of kind of results, but I haven't spent enough time with their data to know how well that's organized and how broadly, but something like that would be really useful, but it's only going to work if it's kept up by a dynamic person who can make sure that farmers and researchers are aware of it and are tapping into it in the way that it could be best used.
Would you say it's a correct characterization to sort of summarize that farmers who are interested in hosting research on their farm should be seeking out those tenured professors at their land grant universities who have the freedom to be a little bit more risky in asking these questions? Don't ask the new assistant professor who just got hired. Or how do you think
No.
those relationships form, and how farmers can approach researchers with questions in a way that might be, digestible for the way research works?
Oh, interesting. I don't think that puts too, so first I would say don't ignore the young faculty because they're coming in potentially with a lot of interesting ideas, etc. And if they don't do research, they won't keep their jobs. So, and also I know you're kind of joking, but it's got to be just about as difficult for a farmer to figure out how to approach academia as it is for academicians to figure out where do I find a farmer. So
I
that,
love that acknowledgement. Yeah.
yeah. So how do you create a system where everybody is meeting each other? And,
Mhm.
you know, how do you figure out which researchers to include? So nobody would have ever included me in, my time as a restoration ecologist because I'm not doing ag work, but, my questions were potentially of equal relevance, but I wasn't talking to farmers. It took me a removal of, to be removed from my busy job and have some time to think to even think about, oh, maybe ag systems could be really interesting to study. I think the challenge is just to create situations where farmers and researchers can talk. And I wouldn't want to put it on the farmer like, okay, how do you pose your question in a way that a researcher will be interested in it? I'd say, how do you talk? How do you find the venue to meet and talk about what's going on in your system and to talk to scientists enough that they can start to understand your system?
Yeah.
Yeah. So I think it's just creating the venue to have those conversations, and nobody needs to come to the table with everything. If you don't want to set the bar too high, like, oh, I've got to know everything about agriculture before I talk to a farmer, or I have to know what the interesting research questions are before I talk to a scientist.
As we roll into conference season, which I consider sort of be the next 6 months, I think there's oftentimes research components to a lot of these organic conferences. And this one, I just am sort of mulling over this idea of really just trying to set up speed dating, farmer meets researcher opportunities, to, yeah, just lay out those two basically profiles. What do I study? What do you farm? Is there any overlap there? And what an interesting opportunity for everyone who's hosting. I'm just thinking about MOA, Montana Organic Association, trying to put that together to introduce you to more farmers who might want research on their farms and doing that around the country. So that's wonderful. I was wondering, Hannah Francis, or do you have any questions or any ideas as the O-Grain conference is coming up, or anything to share about the research efforts that are being explored there?
Yeah. Hi, everybody. apologies, I'm not feeling very well today, so I'm going to stay off camera.
All good.
But thanks for the call. And Cathy, it's so wonderful to hear about all the research and questions that you have and how you've gotten to where you are as someone who's kind of a younger person entering the field. And it's very inspiring. So for the O'Grain conference, one thing that, and I love your idea of like the speed dating thing, Nate. One thing that we tried first for the first time last year was these roundtable sections where people who were interested in a particular topic could host a roundtable and have an informal time to gather with other farmers or people interested in that topic and talk through those themes. And one thing that we're thinking about, and Francois actually, who's on this call, is kind of in charge of our like O'Grain on-farm research component. And I think those roundtable opportunities would definitely be a way to get farmers to talk about what their needs are and how they would want to do research. So we've been talking about this, and it's like it's kind of hard to find the right forum so that people engage and aren't pulled to something else.
Absolutely. We need to just have like a cash prize if you attend. Have a raffle at the end that we get to incentivize the early days. But yeah, I think I'm really excited about this question, especially at this time of year, to see if we can still get some of these farmer meet and greets to researchers going around the country and see what comes of them. Well, thank you, Cathy. Thank you for letting me throw and lob all of these terribly wide-ranging questions your way so early in the morning. And thank you for doing this research with organic farmers, with all farmers. I know Casey Bailey, who couldn't join us this morning, but is really excited about this idea of digging deeper into the why of his farm and how to do better. And you're providing an avenue for a lot of farmers to ask those questions. So thank you very much for the collaboration there. We are going to be meeting next month, folks, and please keep an eye on your email for the announcement. But I hope everyone has a fabulous Wednesday. And again, thank you, Cathy, for joining us. And we'll see you all soon. Take care, everybody.